Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is AUNI binti Muhammad RIDZAL. My number matric is 01DDT21F1004. I'm from class DDT P3A. Today my friend and I will explain about the mini project given by our lecturer Sir Iqmal. Now I will explain the first question. The first question is insert a list of data into stack as ensure the pop operation to remove all elements from the stack. Now I will show you the program that I write. The first thing I do is I declare and create the stack. The next that I write about check is full and check is empty. The main operation in this program is push and pop operation. At it meant I call the push and pop function to show the push and pop process. Now I will show you the output. As you can see here, the first thing you must do to insert the element. But for now, I will insert PUO. As you can see, the PUO already in the stack. You can see that current top is 2, means here that O is the top element at the stack. Now I will show you the pop function. The pop function here that the O will be the first element that be popped from the stack. U will be the second element popped from the stack and P will be the last element popped from the stack. Current top here is -1. This is show that the stack is empty. That is all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is AZIZAH binti HAMID with registration number 01DDT21F1008. And now I will continue with mini project question 2. As we can see, the question is to insert a list of data into QQ as shown in the following figure. So at the end of program, show the DQ operations to remove all elements from the queue. We have 3 elements which is P, U, O in the QQ. So in the C++ program, how to insert a data and to remove all the elements. So this is our C++ program. We start with #include IOStream, #define maximum size 3 because the elements only have 3 size. Then using namespace standard. So firstly we make the function is full, is empty, NQ and DQ. And we proceed with call function. Start with in main. We use char value because the data type of the element is character. So char value A and cout. We use cout like this because we want to make the output more interesting. So we try to compile and run. And now Q is empty because we doesn't insert any element. Now I will insert PUO because the question is PUO. And now we can see element of Q now have P, which is front 0, rear 1. And now when we DQ the element from QQ, P, now front is 1 and rear is 2. When we DQ element of U, the front is 2 and the rear is 2. And when we DQ O element, now front -1 and -1. And now the Q is empty. QQ doesn't have any elements. So that's all.
Hello everyone, my name is KEEVAN and I'm from DDT P3A and my matrix number is 01DDT21F1011. Okay, and today I'm going to write a C++ program to show the implementation of binary search tree using the linked list. In this program, all the operation in binary search tree is included, which is creating BST, inserting item into BST, count item in BST, deleting item from BST, and traversal of BST. That's it. And here we go. And let's take a look at this program. And firstly, we have to put the include IOStream using the namespace standard. And then we have to, with the struct node, we have to declare the node, which is the node of left and right with the integer data. Root equals null, point equals null. With the void create, we have to create the node. And first, we have to enter the size of the binary search tree, and then while size less than c, if root equals null. This is the if else statement, and then we have to enter the value for root node. We have to create the root only for this, and then as you look at this, as you see, for this you have to put the point equals root c out and l, and this is for this we have to put a semicolon. It's important actually. And then you have to enter the value of node. It's the while true, if it's just the same thing as just now. And this one is under the left one, if point left equals null. This is for the left, and then point to left with the new node, point equals point to left, point data equals v, point left, then right, value is entered. Then this is for the left, then we should put the break. And then else, it's the if else, because it's the if else statement. And then next one is for the right. It's the same thing only. We should apply the same thing as the just now one, which is the left. Just now is the left, and now is the right one. Same thing, have to put break, else if point to right, then null. And this is we should enter the number of node in binary search tree with the size. And next we should delete the node, the struct node. We should put the struct node, delete node, struct node, root integer data with the code program for delete node. Now this is also the if else statement, and we should apply all of this. This is really important. Okay, delete node is for left, and this is for the right. The same thing, it's just for the left and right. Delete root equals null. Okay, if else statement. And don't forget, for all of this we should put the semicolon. If you don't put the semicolon, you will get the error. Okay, now we're still in the delete node, delete temp. Okay, and after you finish everything, if you finish everything, you have to put the return root, because it's come to the end. And the next one, we should put the void pre-order. It's under the pre-order traversal. Okay, this is the pre-order traversal, and for that we should put the cout root data pre-order root left, and then the right. And the next one, we should put the void post order node root. This is for the post order traversal, and for the post order traversal we have to put the root left and then to the right. Then it's for the cout root data. And next one, the third one, is the void in order traversal, in order root left, and then cout to the root data, in order root right. And for all of this we have to put the bracket. It's the standard actually, so that you can get all of it perfect. And the next one is the integer main, the final one. It's the final one. Integer main is really important, and for that we should put the integer data insert in the node with a semicolon, and then create. We should apply all of this, because this is the structure of the C++. And then cout traversal order, and the next one is the pre-order traversal, and the next one is the post order traversal order. This actually this is all under the traversal order. So for the traversal order, you have pre-order traversal, post order traversal, and the in order traversal. That's it, just three. And then after you put all of this, you have to delete the item from the binary search tree, and you should put, do you want to delete node, either yes or no. It's the option. And then which node do you want to delete, and then you should put this in node, delete node, and then do you want to delete again, yes or no. This is the insert, C in insert, C out end, C out, delete node for node, and okay, and then the same thing as just now, like this. I mean, yeah, same thing as this. I have to repeat that again. And C out traversal order after delete node, and then pre-order traversal, post-order traversal, in order, just like just now. You just have to follow that again, nothing else. And after you finish all of it, because it's coming to the end, you should put the return 0 with the semicolon and the bracket. That's it, guys, and I hope you guys will understand it, and thank you so much. Thank you very much.
Now back to me with mini project question 4. Based on the figure below, illustrate the steps to find the key of 50 by using binary search method. Based on the figure, we have several of numbers. So the target is 50. We start with step 1. 0 is at the first and 8 at the last. So how to find the middle? So 0 plus 8 divided by 2. So equal to 4, which is 34. And now we can see 50 is greater than 34. So we remove 34 and below. So next step, we have 5 at the first, 8 at the last. So the middle, 5 plus 8 divided by 2 and 6. We got 6, which is 47. As we can see, 50 is greater than 47. So we still cannot find the target key. So we remove the 47 and the below. Move to the next step. We have 7 at first and 8 at last. So how to find the middle? 7 plus 8 divided by 2, we have 50, which is same as the target key. Now we have 50 equal to 50, search found. The target key is found. That's all from me. Thank you.